Our next speaker is one that you're well familiar with as well. John Dickey has been active in agronomic programs in the Valley for a number of years too. And he's going to be talking about the assessment of harvested and sequestered nitrogen in California crops. And I really am looking forward to John's presentation, because without knowing how much nitrogen is being accumulated in the crop and then ultimately harvested, it's not possible to construct an accurate nitrogen budget. We've been waiting for this information, and I'm really looking forward to John's presentation. Let me just give you a brief background about John if you haven't had a chance to interact with him before, but he's all around the state, and he may show up wherever you are. But he is working with the Management Practices Evaluation Program and focusing especially on nitrogen application by crops. John works with several of the irrigated land coalitions, and he's coordinating activities with the U.S. Department of Agriculture, the University of California, CDFA and FREP and commodity groups, and the water control boards. So he's responsible for getting all these groups to talk together. So maybe the last comments of Secretary Ross were applicable to John, because he's trying to address some of these silos that are taking place. So he and his co-authors are working with producers around the Central Valley to refine these nitrogen fertilizer coefficients and nitrogen removal coefficients. So John, we've been anxiously awaiting your presentation and look forward to your information today.
Hey, thanks, Rob. I want to mention that the team we've got listed here of co-authors includes folks from the coalitions Rob mentioned, the South San Joaquin Management Practices Evaluation Program Committee and technical team, as well as Dr. Daniel Geisler, who's our principal UC cooperator. And so we'll talk more about his role a little later. So the topics I'll be running through here are the uses of N removal information in production and regulatory applications, sources of N removal information that we have, and then the irrigated lands regulatory program related N removal projects specifically. We'll run through the crops that are being addressed, the sampling and analysis that's being done, contributions from other studies beyond the scope of the one that FREP has funded and that we have performed, and then an example of some of the results. So first we'll cover the regulatory applications of these N removal and sequestration rates. And this pertains mostly to the Central Valley region of Regional Board domain, which is really the Central Valley watershed, where the irrigated lands regulatory program makes particular use of these N removal rates as part of a metrics to track the success or progress of the program. So N removal is important, of course, because we apply N to the field and then we take it back out of the field. And so the relationship between those two things in general can tell us something about the risks to water quality. And of course, we remove it from the field in various ways. So the N balance then is the difference between the applied N and the removed N. And that N balance then, many things can happen to it. And one of those things is that it can leach to groundwater, which is why its N removal is of interest in a water quality program. It doesn't mean it does leach to groundwater, but it can. So it's sort of a metric that's related to risk. Another way that the N removal can be formulated with applied N is to form a ratio, either an efficiency ratio or the inverse of an efficiency ratio. So the inverse of the efficiency ratio is the applied N divided by what's removed, which is, it's kind of most famous in the dairy program, where I believe a target of 1.4 is what dairymen are meant to try to hit, which corresponds to about a 71% N use efficiency. So these are kind of the ways that it's used on the regulatory side. It's formulated in these ways. So what's counted as N removal among all the sources of N that exist? It's what's applied, either in organic or chemical form, and including, and it's in irrigation water. In the Irrigated Lands program on high vulnerability groundwater areas, growers report that applied N to their coalition. And then along with that, they also report the yield of their crop. And then in an N removal coefficient that includes kind of corrections for the amount that might be removed from the field in other material and might be incorporated into standing perennial biomass, that N removal is calculated by the coalition and then generalized and furnished to the regional board. It's also used in the Irrigated Lands program just to track agronomically kind of what's going on and how our growers are using nitrogen and what they're getting for it. You know, the production applications of N removal, I think everybody's even more familiar with. It's primarily used in N management planning. It's just part of a comprehensive or partial N balances that are used to decide how much fertilizer to apply, how much is needed. And there's a reference tool where you can find these N removal rates if you don't know them for your crop. And then they can be incorporated into your N management planning, where you kind of sum up all the N that you plan to apply and make sure that that balances with what's being used in the field. And you take into consideration the potential losses along the way and try to reasonably minimize those environmental losses like leaching, etc. So they're really just, the N removal is just part of the N balance toolbox. If this kind of vertical axis is the amount of N per acre per year, that N balance is a proportion of that total N balance in the field. So you got the N applied and the N removed, and that difference then is the N balance. So how do we keep that N balance as small as possible to minimize this the risk of environmental losses? Well, turns out that most of the tools are the same things we do to try to grow our crops productively. We try to avoid applying N efficiently. We try to avoid applying more N that's needed by allocating N for harvest, sequestration, and other removal and unavoidable losses. We need to recognize all the N efficiencies. So for instance, if we're irrigating very carefully, we may not need as much N because we're washing less of it through our root zone and our crops have a better opportunity to absorb it. Take into account all the N sources, not leaving out irrigation water, mineralization of organic N, contributions from cover crops or organic amendments, testing tissue to make sure that we're on track, all our calculations are playing out the way we thought, and avoiding wasteful applications. So often perennial crops, fall applications don't really provide much benefit and therefore can be kind of reconsidered and maybe avoided. There we go. And then on the N remove side, to make sure we get as much as we can into our crop, just matching the amounts and timing to the crop needs throughout the season with maximum uniformity, irrigation and uniformity of water and fertilizer application are a huge challenge and opportunity to get better recovery. All those little spots in our field that are a little different, sometimes they're not as efficient as the best spots in our fields. And so maximizing uniformity is super important. And then addressing other yield limiting factors so that the N we put on is not being sucked up by weeds, or we don't have other things that prevent the crop from being able to use the N. So I'm just going to observe that when you look at this toolbox, it's almost the same one that we use to produce the best possible crop. So in this way, productive agriculture and water quality protection are compatible, which is a good thing for the Irrigated Lands program. We really try to focus on these win-win types of approaches to achieving our water quality protection goals. So now we talked about how the N balance is kind of an index of risk, but how does it really relate to leaching? And so we modeled leaching for a lot of crops, and each of these crops is signified by a letter out here. We've got red and green letters. The red letters are the most efficient irrigation and nitrogen management. The green letters are less efficient irrigation and nitrogen management. And you might notice that if you look at the end, as the end balance grows, as you get less efficient, the end balance gets bigger, and the amount of leaching is generally more. So if you look at these two, that's the way they are. And there are pairs of letters for all these different crops that are out here. So when we look at this, the things we notice for these 28 crops is that more efficient N and water management tend to reduce the N balance, bring you this way, and they also reduce leaching. That's kind of straightforward. So the N balance is important, and removed is important, as Rob kind of mentioned at the beginning. A greater N balance tends to be related to higher rates of N leaching. So it doesn't equivalent to it, but it does pan out as a pretty good risk indicator, although the level of risk for different crops is obviously different. So it doesn't always mean the same thing, but as it gets bigger, it always means greater risk. And the N leached is nearly always less than the N balance, as one would expect due to the many other possible fates of applied N. N, as we know, can be stored in the soil and taken up by the crop the next year, and other things can happen too. So it's incorrect almost always to equate the N balance with N leaching. I just want to mention another application of these N removal rates. They're used various ways in the Irrigated Lands program. All the modeling we do, for instance, has an explicit assumption of N removal rates as crops develop. And that's for all of these 3 modeling domains to cover the entire Central Valley. Well, it's really used for all of the above, except enforcement of water quality regulations. It really hasn't been used for that. It's used as a metric in the program, but there's no history and no explicit plan to use it for enforcement of water quality regulations. So that's, in a way, a trick question, but good responses and interesting responses. Our approach to these getting N removal rates in these studies was to establish usable coefficients based on the literature. The Irrigated Lands program started up and needed coefficients. We didn't have time to go do years of research, so the literature was the first and best place to go to get rolling. Then to canvass the research community for better information on crops requiring more attention, and use the results to refine as many as possible. This too could be done pretty quickly. It didn't require new research because of gray literature, things sitting in people's files, ongoing research, etc. And then where necessary, we work to obtain and analyze new samples from the industry and some samples from research partners. The approach is to identify the least invasive point to obtain representative samples of harvested material. That makes things more convenient for everybody, the people providing the samples as well as ourselves. And then the ideal is to subsample or sample alongside some established crop quality assessment points. All crops are assessed for quality so that they can figure out how much payment is due to the grower, for example. And so those are the best intervention points. You're sort of piggybacking on a process that's already in place. Dr. Geisler then stores, processes, and analyzes the samples. Then he interprets the results to produce an updated N content coefficients. We obtain yield information, or various field information, the N rate, the variety, the yield, the harvest date, age of the perennial crops, the quality of the crop, to provide context about the samples so that the interpretation can be a little richer and more informed. So we've done 3 studies over about 7 years. We're now in year 4. What I call phase 0 is a literature review by Dr. Geisler that is available online, and also in that N removed tool that I provided the URL for previously. Covers about 72 crops if you count wheat, straw, stuff like that. And when you look at his analysis, he provides an explicit discussion of the relevance of the data to the contemporary condition of farming that crop in the Central Valley. And about 11 of them had really on target data underneath them. So covering about 39% of the acreage. So phase one of the crop, which is ongoing, of the project, which is ongoing, is to dig into existing studies and files for a few crops and kind of update those coefficients based on those studies. Some of those studies were ongoing, and then to go out and sample crops where really there's no work taking place and no kind of high gray literature hiding in people's files. That boosts the solid coefficients to about 82% of the acreage. So we hit a lot of the big acreage crops in phase one. Phase two, which is just about to start, these are both FREP-funded studies, I should emphasize, we're going to cover a lot more crops, probably fewer samples per crop, just to be able to get through all of them. These are smaller acreage crops, but altogether should boost our solid coefficient to about 99% of the acreage. And this is really the type of coverage that the regional board is looking for from the coalitions, and so that's why we're trying to boost it to that level. So the solid coefficients from the literature review were for these crops, for which there was a lot of good solid current work. In phase one, the phase we're in, we've obtained samples or gotten gray literature for all of these crops. In some cases, for instance, Pima cotton and upland cotton, there's some work ongoing by Bob Hutmacher, and that's separately funded, but we'll be using those results too. We always like it when somebody else does our work for us. That's the easiest way to get things done. And all the crops have been sampled. We've worked with various producers and processors. Oh, and I should mention the FREP grant is to Kings River Conservation District, really the fiscal entity for the South San Joaquin Management Practices Evaluation Committee, and that those 7 coalitions who are members are working with all the other Central Valley coalitions also as kind of partners. Phase 2, again, covering a much greater number of crops and probably fewer samples per crop. So this is about what we're wading into. So if you grow any of these crops or process any of these crops, we may be looking to you for some assistance in obtaining samples. So the lit review looked like this. There were some nice tables of coefficients like this, and they were in there for field crops, also for veg crops, and for perennials. Quite a comprehensive piece of work. So how do we get these samples? So this is just an example. Processing tomatoes, we partnered with Processing Tomato Advisory Board, canneries and producers, and obtained representative samples. They were already pulling these at grading stations. They spent millions of dollars on a really sophisticated way to get representative samples, so that they're already, all we have to do is subsample a little bit of the juice that they pull out of these. So first they take some tomatoes from the gondola, and I should mention that the preliminary results show that these samples represent fields very well, although they come from individual loads. On the grading table, there's a subsample of tomatoes that are put in a blender, and under vacuum they're blended up into juice, and then that's taken down a shunt where a number of parameters that are important to the tomato quality evaluation are measured. But we just get a little bit of that juice and send it to the lab and analyze its nitrogen content. So that's a really straightforward way to get a representative sample. So this is just an example, but there are similar interventions for all the other crops with processors. So we have preliminary results for about 845 samples, about 9 crops. 3 crops are pending. You have kind of a variety of results. This is comparing the 2016 literature review to the results from the newer sampling. In some cases, the results are giving us very similar values, for instance, for silage corn. The in pistachios, they're looking at a different basis, kind of a fresh, a net fresh pistachios as they arrive to the plant, as opposed to the in-shell pistachios that are processed. So that's just a different strategy that may prove more accurate. With pomegranates, just it's a significantly lower coefficient than was in the literature, and with tomatoes a little bit higher. So kind of that's why we're doing the study. You might expect the samples from fields to be much more variable than samples pulled from research plots or something, which is where a lot of the literature was. So the red bars are our literature coefficients of variation compared to the coefficients of variation for 2018 and 2019 sampling. And so not in all cases, in pistachios, we change the basis, but in general, the coefficients of variation are similar or less. They're not systematically higher. And so it's proven to be a reasonable way to get good representative samples. Things that affect N removal should be remembered, especially when you're doing nutrient management planning. This is N applied to peaches and the percent N in the fresh fruit. These are literature values. Generally, as you apply more N, you end up with more in the fruit. Not surprising. What is surprising is that our samples of late, mid-season, and early peaches from California, these are our samples from 2017, they're recovering more N at the same rate than the literature would show. And so again, that's why we do these studies. California isn't just like everything else, and so we got the site-specific work was helpful. We also learned that in peaches, for example, the length of the season has a strong effect, or a significant effect, on the N content of the peaches, so that as the season goes on and carbohydrates get loaded into the fruit, that really dilutes the nitrogen content. So early peaches tend to have more nitrogen in them. So one option for the industry is to take that into consideration. Another is to just use a weighted N removal factor and kind of on the average get generally the right amount of N balance. Just sort of to show how they're applied, if you have a net green pounds per acre of pistachios of about 6,000 pounds, and the yield in the concentration is about 20 pounds per ton. That gives you about 60 pounds of nitrogen removed. Into the pistachios, into the wood, maybe 25 or 30 pounds. You add those together and have about 90 pounds of N removal. Question 2. I agree with the poll. Well done.
Okay. And did folks get it right? Is green or nut moisture content a consideration?
In a sense, yes, right? Because if it's with grains and nuts, it tends to be you tend to have a standard moisture content, and if it's a standard moisture content and the N removal rate is tied to that standard moisture content, you need to use your numbers need to be expressed in that standard moisture content. So in general, it tends to be taken out of the equation because it's already built into the N removal coefficient.
All right.
So I put that in so that we could mention that.
All right. Very good. Back to you.
Thank you. All right. So in summary, the N removal rates by crops are used as regulatory indices to improve the irrigated lands program leaching assessments and leaching assessments to provide an indication to growers what their N leaching risk is in a rough way, and then to estimate N needs as part of N management planning. This is part of a larger tool set that growers use to minimize their N balance and their N leaching risk while growing a good crop. We developed literature-based average N removal rates for 72 crops, and these coefficients are in use by the irrigated lands regulatory program coalitions, and then solid coefficients for about 99% of the Central Valley acreage will result from all 3 studies. The latest are available online. A lot of the revised coefficients are based on samples obtained in partnership with grower-packer shipper cooperators. you need to use the yield basis that's specified for the coefficient. That is the units, the stage of processing, the standard moisture content, or fresh weight, depending on what's specified when you do the calculations. And these are built into the online calculator. And then the removal rate variation due to end application rate, yield, season duration, or other factors can be considered where greater precision is needed. So with that, I just want to acknowledge our member coalitions in the Southern San Joaquin Valley of the South San Joaquin MPEP committee. Especially thank our mostly anonymous collaborating grower packer shippers for all their insights and help with all aspects of the project. The University of California for sharing Daniel Geisler and his team with us, and lots of our friends and supporters throughout the industry.
Well, thank you, John.